Good day everyone, my name is Fadi Masood and I will provide you with a quick overview of Infinera's DTN X platforms, as well as the Flexible Open Line System or FlexILS. Before we dive into the product details, let's take a look at the challenges communication service providers or CSPs face today. We can summarize those challenges with 1. A massive bandwidth growth that is triggering significant capex. 2. The bandwidth growth is increasing network complexity and its recurring cost. And 3. Slow operations that are impacting revenue streams. So, why Infinera for long-haul networks? Well, we can summarize Infinera's value proposition in 3 points. Number 1 is the ability to provide massive scale with lower total cost of ownership, and that's done with the super channel, the ability to provide vertical integration, and many other examples. Second is the ability to provide network efficiency in driving down OpEx with simple network design and operations, reduced power and space. And third is the ability to provide industry-leading reliability as a competitive edge with the PIC, which has more than 9 times the industry reliability standards. All this over an open and secure infrastructure. The massive scalability I mentioned earlier is enabled by Infinera's innovation in photonic integration or PIC. It's the ability to scale to multiple terabits quickly, cost-effectively, and without network engineering or disruption to day-to-day operations. On this slide, we can see some of the features that enable superior scalability and optical performance. Infinera's Advanced Coherent Toolkit, or ACT, provides Nyquist subcarriers, SDFEC, gain sharing, pulse shaping, high gain SDFEC, and many other features to enable terabit networking without compromising reach or capacity. One example of Infinera's unique implementations to deliver high capacity is superchannels. Infinera superchannels provide a better spectral efficiency that lead to higher capacity per fiber. That could be in the order of 2 terabit per second. As mentioned earlier, one of service providers' challenges is slow operations that impact revenue streams. Infinera solves this problem with software-defined capacity, or SDC. SDC allows the fast turn-up of bandwidth without truck rolls. It also enables programmability and automation of service turn-up to accelerate deployment, reduce operating costs, streamline operations, and eliminate the sources of human error. Infinera's DTN X platforms are also equipped with numerous features to enable a new level of programmability, such as advanced APIs, microservices-based software, as well as Exceed, Infinera's SDN multi-layer controller. Now let's take a look at Infinera's DTN X platforms. We can distinguish 2 series, the XT series and the XTC series. Let's start with the XT series on the left. The XT500 is a compact 2-rack unit 500 gig line platform that is based on the 3rd generation of the infinite capacity engine, or Gen 3. The 2 platforms on its right are the XT3300 and the XT3600, which are powered by Infinera's latest optical engine, ICE4. They provide 1.2 terabit in 1 rack unit and 2.4 in 4 rack unit respectively. The XTC series has 4 products, starting from the right, the XTC 10, the XTC4, the XTC2, and the XTC2E. Infinera's optical line system underpins all these platforms, and we will cover every single platform in more detail in the next few slides. Also, Infinera's DNA provides an end-to-end management over common network operating system and node management. Now let's take a closer look at the XTC series. Starting from the right, we can see the XTC2 and the XTC2E. They provide multi-service aggregation and transport for low-capacity metro sites. They currently offer 1.2 terabit of switching and transport. However, they will be soon equipped with a new circuit pack called the MX400 that will increase the shelf's capacity to 3.2 terabits. The XTC2E offers 6 additional slots for optical line modules. The XTC4 and XTC10 platforms combine transport and switching in a single box and designed for high-capacity switching and transport on long-haul and subsea networks. The XTC4 has 4 slots while the XTC10 has 10 that can be equipped with a wide variety of client and line modules. Here is a closer look at the XTC4 and XTC10. They offer multi-layer switching and OTN mapping and multiplexing. They recently supported ICE4 that elevated each shelf's capacity to an unprecedented level. The XTC4 now offers up to 4.8 terabits, while the XTC10 offers up to 12. They're both powered by the Advanced Coherent Toolkit for a maximum optical performance, such as super channels, Nyquist subcarriers, flexible modulations, sliceable optics, and many more. They're also feature-rich when it comes to client interfaces, covering OTN, SONET SDH, Ethernet, SAN, and Packet. They're built for network automation, native open APIs, compatibility with Infinera, as well as third-party multi-layer SDN controllers, are just few examples of how the XTC4 and XTC10 can play a key role in automating and streamlining service operations. The XTC2 and XTC2E are built for low and medium capacity service aggregation sites. They offer programmable client interfaces from 1 gig to 100 gig and beyond, with a variety of protocols, such as SONET, SDH, OTN, Ethernet, storage, packet. The XTC2E additional slots can be equipped with optical line modules, such as CDC ROADM, amplifiers, filters, and so on. And similar to the XTC4 and 10, they're open and programmable. This slide highlights the benefits enabled by the upgrade to ICE4 on the XTC4 and XTC10 in terms of capacity per slot, total fiber capacity, reach, and so on. It is important to know that the upgrade to ICE4 is done in service, within the same footprint and without forklifting or any change in power. This upgrade translates to lower cost and lower watt per gig, in addition to a significant enhancement in scalability and optical performance. We can summarize the benefits of upgrading to ICE4 as follows. First is a great scalability by increasing the slot and the shelf capacity by a factor of 2.4, all within the same footprint and without any change in power. 2, better economics, up to 50% power savings per gig, lower cost per gig, lower watt, higher gig per rack unit, and all this in service. And finally, an enhanced performance and flexibility to accelerate service delivery and streamline operations. Here is a quick overview of the XTC series target applications, spanning from terabit terrestrial or subsea transport, OTN multiplexing and switching in core networks, mesh transport network for maximum capacity and service availability, multi-layer optimization. There are a wide variety of applications where we can use the XTC4 or XTC10 or combined. Now let's take a look at the XT series. The XT series is a series of web-scale disaggregated platforms. There are three different types in the XT series. The XT500, which is powered by the previous generation of Infinera infinite capacity engine called the Gen 3. The XT33 and 3600. Both the XT33 and the 3600 have a flavor optimized for long-haul and subsea applications. This is distinguished in the name by the letter S as the XTS3300 and the XTS3600. Now let's take a closer look at the XTS3300. The XTS3300 provide 1.2 terabit capacity in a compact one rack unit footprint. They provide cost-effective and flexible delivery of 100 gig client interfaces over the 1.2 terabit super channel-based line with flexible modulations, sliceable optics, and instant bandwidth capabilities. The XTS3300 are also powered by Infinera's advanced coherent toolkit for a maximum capacity and reach. They're also carrier-grade, NEPS compliant, and offer the choice of AC or DC power supplies as well as a hot swappable controller. The XTS3300 have been designed with open and programmability in mind, with a complete set of open APIs and support of multi-layer SDN controllers. Now let's take a closer look at the XTS3600. The XTS3600 provide higher capacity than the XTS3300 as well as additional type of client interfaces. The XTS3600 provide 2.4 terabit capacity over a super channel based line in a 4 rack unit form factor. In addition to 100 gig, the XTS3600 provide 10 gig as well as OTU4 OTN client interfaces and can be deployed in an XTC4, XTC10 network once upgraded to ICE4. The XTS3600 are also carrier-grade, NEPS compliant with redundant AC or DC power supplies, redundant controllers, and redundant fans. Similar to the XTS3300, them too are designed with open and programmability in mind, with open APIs and the support of multi-layer SDN controllers. The XTS3600 can be deployed in a wide variety of applications as depicted on this slide. Point-to-point, long-haul and subsea, mesh networking by leveraging super channels and optical sliceability, as well as high-capacity Metro Ethernet transport, leveraging the high density of 100 gig in such a compact footprint. Now that we've seen the XTC series and the XT series, let's take a closer look at the optical photonic line that underpins them all, Infinera's FlexILS. Before we go over its building blocks, let's cover the key features of FlexILS. First is the Flex ROADM that provides CDC capability as well as point of optical flexibility in the network. Also, the Flex Grid that provides additional fiber capacity and more flexibility in Flex Grid. The optical sliceability that we mentioned earlier further increases the benefits of super channels by allowing any super channel to be sliced into one or multiple 100 gigs that can be tuned across the C-band, modulated, and then routed in multiple separate directions over any open optical line system. And finally, C+L band is the ability to double the fiber capacity by transmitting in the L band and hence maximizing spectrum utilization. FlexILS FlexGrid allows a more efficient use of the spectrum while paving the way for multi-terabit networking. In fact, using FlexGrid and high-order modulation, Infinera's FlexILS can scale up to 55.2 terabits per second when using 16 QAM over C and the L band. The building blocks for FlexILS are depicted on this slide. Starting from the left, FlexGrid CDC ROADM for optical switching, MUX DMUX units for individual channel or super channel multiplexing, M times N switches, a contention-less add drop, coherent optimized amplifiers, which implies DCM-less operations for better performance and better reach, chassis to house the modules mentioned above. Soon, Infinera's FlexILS will be further enhanced with the introduction of L-band ready line cards. On this slide, we can see both the MTC9 and the MTC6 chassis that house the multiple optical modules such as ROADM, amplifiers, MUX, DMUX, and many other functions. Infinera's FlexILS leads the industry in the move toward open line systems, as any third-party terminal can be deployed over Infinera's open FlexILS. Similarly, OpenICE allows the deployment of Infinera platforms powered by the Infinite Capacity Engine over any third-party line system, whether in a FlexGrid or a fixed grid deployment, to enable multi-terabit scalability, flexibility, and efficiency. With that, we conclude this quick overview of the DTN X and FlexILS. Please visit our website for more details. Thanks for attending and have a wonderful day.